Alrighty, I'm very excited about this video. Not just because it's FTC Part 2, it is one of my favorite topics, but it's going to be our very first modern video where you have the calculator on the right side and then the problems on the left side. So I am not switching back and forth with the calculator and Notability, which is a win for me. Now for you guys, you probably don't care, but at least you could see both things side by side. But in other news, there will be 8 videos, one for each FTC Part 2 FRQ. And as you guessed, since there's 8 videos for FTC Part 2, it is a heavily tested topic on the FRQ. In May, there were 2. There was 2025 AB1 and then 2025 AB4. So I'm just telling you out right now, it's my favorite topic and it's the most tested. All right, so we have an invasive species, and it gives us that the function for that invasive species is c of t is equal to 7.6 arctangent of 0.2t. And it also gives us the derivative c prime of t. So that was very nice of them to give us the derivative, especially since we don't technically know the derivative of inverse tangent yet in terms of transcendental functions. But lucky for us, this is a calculator active problem, so you don't really need to know that. Now for part A, it says find the average number of acres affected by the invasive species from time t is equal to 0 to time t is equal to 4 weeks. Show the setup for your calculations. All right, anytime I'm thinking about the average number of acres, I need to think about, is this average rate of change or is this average value? Now, if you look at our units here, we are looking at the average number of acres. So if I'm doing average rate of change, that's going to be, let's see, acres per week. I don't want that. I want average number of acres. So what I'm going to do is put an integral, aka my average value, of 1/4 the integral from 0 to 4 of c of t dt, and then call it a day. There's your setup. I'm going to go ahead and put this in y equals, my function in y equals, so 7.6 arctangent of 0.2x. And then I'm going to go ahead and do my average value formula in my handy dandy calculator. You can see everything that I'm typing, and I don't have to go back and forth. Like, I'm so excited, so happy. So this gives us 2.778 as our answer. And that's all you have to do. Part B, we love telling you guys find the instantaneous rate of change and when is equal to the average rate of change and all that good stuff, aka the mean value theorem. So we are going to find the average rate of change here from 0 to 4. Now, whenever we find the average rate of change, theoretically, whenever it says show the setup, you do not need to give me the numerical answer. The setup would just be c of 4 minus c of 0 over 4 minus 0. That's my average rate of change. And then I have my instantaneous rate of change, like that right there. All right, so I need to figure out what my average rate of change is. So I am going to go to y equals. I'm going to make that average rate of change. So that's going to be y1 of 4 minus y1 of 0, 4 minus 0. And then I also want the derivative. Since they have already given me the derivative and what that derivative is, I'm just going to plug it in. Now, can you do math 8 and do the derivative that way? Yes, you'll get the same thing. Let's see, I'm going to go ahead and uncheck this. And then because it is from 0 to 4, I probably want to change my window so that my x min and x max is from 0 to 4. I'll keep my y min and y max to be, let's do 0 to 10. Graph this. Okay. Maybe do something smaller, like 0 to 3 if you really want to, like, see it. There we go. Okay. So then we want to find the intersection here. So we're going to do second calc, intersection, find your left bound, find your right bound, get that intersection, and it looks like it's 2.1543. Of course, this calculator is a little bit more advanced, but you'll see that it's just t is equal to 2.1543. All right, so part C says, assume that invasive species continues to spread according to the given model for all times t is greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Evaluate this limit expression. It tells us rate of change, aka C prime of t. So basically, this is just asking you, hey, what is the limit as t approaches infinity for C prime of t? Now, because they gave you C prime of t, and because we're substituting in infinity here, we know that this is going to approach 0 because whenever we plug in a very large number here, the numerator is going to stay 38. The denominator is going to grow faster without bound. So this right here is going to approach 0. And then our favorite part, finding the maximum value. In this case, we want to find the time t in which we get the maximum value for a. All right, so in order to do that, we need to take the derivative of this. So this is where FTC part 2 kind of comes into play, because whenever we take the derivative of this, we are going to get a prime of t is equal to C prime of t. And then at this point, because we are taking the derivative of this right here, that x just turns into a t, and then the derivative of t just becomes 1. So then we just get 0.1 ln of t. We are going to set a prime of t equal to 0. In this case, because I don't need y3 anymore in terms of this by itself, I'm just going to do that minus 0.1 ln of t. I'm going to go ahead and uncheck this. Oh, well, maybe I needed that. No. Well, maybe I need a of t, but I'll do that later. I'm gonna focus on finding the 0 here. This is from 4 to 36, and since I'm finding my 0, I'm gonna change my y min and y max to be from -1 to 1. Okay. Now this, they already did it for me, but your calculator probably will not. So on your calculator, do second trace, find your zeros, you'll get 11.441. Now, because we're trying to find the maximum value, remember that you need to look at your endpoints and your critical point, in this case, 11.441. So whenever I'm making my table here, I'm going to do t, I'm going to do a of t. This is going to be 4 and 36, aka my endpoint. And then if you want to label this as T1, then this can also be T1, as long as I know that, hey, this label represents 11.441. Okay, so I'm going to go back to Y1, and I'm going to plug this in. Now, under Y4, I'm going to have alpha calc, alpha trace, Y1, because that's C of t, minus the integral from 4 to t and then I have 0.1 ln of x. dx. 0.1 ln of x dx. Oops. Hopefully that doesn't do anything crazy there. Oop. Okay, I think that's good. And then I'm going to plug in 4, and then T1, and then 36. So then I could do alpha cat y1, and then if I do x here, that's going to represent, let me not do that. Let me do alpha trace y1. I don't know why to do that. 4. That's going to give me that. That's not good because I don't want that. It's y1 minus the integral from 4 to t 0.1 ln of x dx. Oh, duh, it's y4. Okay, silly me. I should be doing y4. Oh, let me... Okay, so y4 of 4 gives us 5.1280. Alpha trace y4 of t1, in this case t1 is 11.441, which gives us 7.3169, and then y4 of 36 gives us 1.7430. Now, remember that another option for you to do this without, typing all of that is using second window and then using independent for your table ask and then plugging in 4, T1, and 36. I think that would be a faster way for you guys to do that. But you do whatever you prefer. Anyways, this tells me that at time T sub 1, aka at time 11.441 weeks, A is going to attain its maximum value. So you're going to write that little sentence there that just says that A of T attains its max value when T is equal to 11.441 weeks. Notice how in my little statement / response, I did not include the Y value because it did not ask me anything about the Y value. So please do not write the Y value. You're just giving me too much information. Don't do that. All right, so that was 2025 AB1. In video 2, we are going to be doing 2025 AB4.